Please join me welcoming Dipti Vachani. Thank you. Thank you.
Ohio gozaimasu. Thank you. I got a couple of responses. It is wonderful to be back here in Japan. Yesterday, we took a train to Nagoya, took the fast train to Nagoya, and I saw this most beautiful, clear view of Mount Fuji. It was magnificent. So it's wonderful, wonderful to be back in this country. And what a time. What a time we're in this industry. We are in a time with the most significant transformation in our lives. The world is changing, and we're seeing the biggest shift since the internet, the smartphone. What am I talking about? AI. We're seeing a shift in AI. And in 1 year, we've seen a shift in the folks that have been coming to these tech symposiums. 30% more people here in the audience. So thank you so much for your interest in Arm. Thank you so much for listening to us, investing in us, trusting in us. 13% developers. We can't do this without you. I'll talk about software and how important it is. And 40% increase in OEMs. Because without you, we actually don't build anything. We need you to build the beautiful cars and infrastructure that we build, the IoT devices. And in this shift of AI, like I said, we are going to see the most significant change in our lives. This isn't a hype. This is truly our industry changing. Of course, you've seen the applications when you open your phone and you see, the camera recognizes you, okay. Or Siri, okay. LLM models, maybe you use ChatGPT. My daughter was applying for internships this summer, and she sent me this resume. She says, "Mom, what do you think of this resume?" And I said, "I think you didn't write it." Because, of course, she went to ChatGPT, and it was beautiful, perfect resume. So, of course, there's those. But it's much bigger than that. It's much bigger than that. That's just the start. What it's going to do for our lives, I truly believe, is going to transform it. But today, what I want to talk about is we're on a collision course with reality. We're dreaming. And our dreams are not going to come true if we keep going the way we've been going. Because what AI needs is so much more than any other level of compute we've ever seen in our lifetime. And so we have all these dreams, and every one of you, I can talk to you, and you'll tell me you have some idea of what AI can do for our lives. But we're never going to see this become real unless we truly solve the fundamental problem that we have. AI's insatiable energy needs, not sustainable. Of course, I got to quote my boss, Rene Haas, the CEO of Arm. AI is ravenous for energy. Today, global data centers consume more power than the entire country of Germany. By 2030, we will consume more power than the entire country of India. This is not manageable. And we have to do this differently. Because if we don't solve this problem, we're not going to see the magnificent value that AI has for us and what it can truly do to change our industry, our lives, the way we do work. And this is the reason we do these tech symposiums. This is the reason I am here with you. Because if I could do all of this sitting in my office back in San Jose, forget it. There's no need to be here. But I can't. I have to do this with you. We have to do this together. This is the reason we have software developers here, OEMs here, silicon providers, manufacturing, because it takes all of us. To truly fundamentally turn the equation on its head, change the equation, start with power first. Start with scalability first. Start with software first. If we start to think about it that way, we have to work together to do it fundamentally different. I'm going to take a moment to talk about the potential, because unless you have a dream, none of this really matters. It's the dream that we're trying to fulfill. The reason we're here is because we all know that we can change the world. We all know that AI has the potential of changing our lives, our children's lives, and everything we do. And it's in that dream that we choose to do things differently. The DeepMind founder was awarded the Nobel Peace Prize. Nobel Prize for Chemistry. Let me get that right. Gosh, my words are getting stuck today. The Nobel Prize for Chemistry. And that is because he was able to use AI to predict how protein complex structures work. And protein is the essential for everything our bodies do. Muscles, light, turning food into energy. Understanding proteins can help us solve the most complex diseases in the world. And we can do that through AI. What took us 50 years took us 10 years because we were able to do with AI. This is the kind of dream I'm talking about. Yes, there's ChatGPT. Yes, there's LLM, and it's cool, and my daughter can write a resume much faster. Great. But we're talking about truly fundamentally solving big problems in this industry. We're able to reduce the cost of R&D for some of this technology by 50%. This is the barrier to entry. This is why these drugs don't get in our hands. Of course, all of us know of drugs that are available. They don't get in our hands. I want to tell you a very, very personal story and why this is so real to me. This is my niece. Her name is Eva. She's near and dear to my heart. I think she looks like me, but that's just my opinion. She's 13 years old. She doesn't look like she's 13. She probably looks like she's 7 or 8, maybe. She has a genetic disease called beta thalassemia major. I have beta thalassemia minor. It is a genetic disease that goes through her family, but hers is much more significant than mine. Her red blood cells in her body do not carry oxygen. Can you imagine? You wouldn't survive. You die. If your body can't carry oxygen, you die. So she has to have blood transfusions for every month. Every month in her entire life since she's been born, she has to go to the hospital and have blood transfusions. Because of what we can do with AI, and this is magnificent, because of what we can do with AI, we have been able to find a way to modify her genes. So, there is a new technology that just came out. Sorry, this is my family. There's a new technology just came out called gene therapy. Next week, on November 12th, my little niece is going to go to the hospital, and she's going to get this gene therapy. And via this gene therapy, she will be cured. She will be cured. There's no side effects, and the success rate is almost 100%. Can you imagine that? What kind of world? This is the world we are creating, where we can truly make people's lives better. And so we hear people talking about AI use cases and wow, is how it's going to change the world. But there truly is ways we can make the people and the ones we love around us, their lives better. And this, we never thought, when she was born, the doctors told us life expectancy of about 15, 16 years old. She can't survive longer than that because the blood transfusions only temporarily solve the problem. She's going to live to be an old lady because we can solve this through AI. And this is the kind of stuff we're talking about. But in order to do this, we have to work differently. And I'm going to get back to the keynote as itself. This is a very emotional point for me. But there's a really big opportunity here in Japan. Japan Market Ministry of Internal Affairs and Communication says the AI market is over 1 trillion yen here in Japan. Use cases like smart cities, healthcare, automotive. The market is here too. The market is near and dear. This is actually the only tech symposium I'm doing. We trade them off between us, and this is the one I chose because I truly believe there is great momentum here in this region in solving some of these fundamental problems. And we are investing in Japan. And we are investing to make sure that happens. Most of you know ARM as what we can do in mobile phones, right? Our history, our 30-year history started in mobile phones. We make the lowest power compute in the world. The first product we ever created, the first CPU, worked off of latency power. Can you imagine that? You know, it was the lowest power silicon ever created, the lowest power CPU ever created. And that was in mobile phones 30 years ago. That fundamental way we think, the fundamental way we believe we create, it's in our DNA, it's in our culture. We do things differently. And that started with mobile. But that's expanded. Now we're doing it in IoT, and healthcare, and smart cities, all the elements that are IoT, automotive, the car. It's reinventing the car. The car is basically a data center on wheels. We need that much compute. How do we do that without the power? So reinventing how we do it in automotive, data centers, that's the biggest power consumption there is, right? Data centers can't be scaled. So we're solving this problem across these vertical industries. But we can't solve it the way we've always solved it. I just said, if we do things the way we've been doing, we're not going to solve anything. We're not going to be able to do the kind of things that we're doing today with AI. We have to think about this differently. And that means thinking about the problem as a system. Hardware, software, ecosystem. We have to solve all three, and we have to work together to lead through those three areas. And what's that mean? What does that mean when I say hardware? For ARM, that means I've got to create not just IP, because I can create the best low-power CPU, GPU, ISP, interconnect, you name it. We have it. But I have to put that together, because the power isn't just a CPU or a GPU. It's a system problem. And so what ARM can do is pull these components together to give you the lowest power platform. Not just the IP, but the platform. But I still got to give you performance, because I sacrificed that. Forget it. We're not going to see our dreams come true. And then I have to make sure you get it to market as fast as possible. Otherwise, we're not going to see our dreams come true. We all have a dream to have all of this get into market as fast as possible. And so that's where our time and investment has been. Let's start with the compute platform. What is an ARM compute platform? Well, you know what's best for our CPU, so of course that's the center of the universe. You see how we draw this? You can tell our bias. The CPU is the center of the universe. So of course we do CPUs, but we do NPUs, GPUs, ISPs. We pull them all together. We verify this block. We certify it. We make sure it just works. So that it helps you get the best performance, the lowest power, and get to time to market as fast as possible. And it allows you to spend your time and energy and valuable R&D on the parts that differentiate you. Because this stuff is what you build off of. It's not really the element that's making the biggest difference in your product. And then what we do is we deploy them into different end equipments, because one size does not fit all, as we know very well. So in infrastructure, we have our Neoverse line of products. There we deploy CSS and Neoverse. Mobile phones, we have a CSS, for that is a mobile, as well as large screen compute. In automotive, of course, we have a CSS that is a bank of heterogeneous compute, CPUs, ISPs, NPUs put together into a verified block. And then we allow it to be scalable, because every one of these have to be scalable. There's not one size that fits all, even within the vertical. So great, you put all this hardware together and you verified this block and you made it work. You really didn't solve a problem, is what you'll say to me. Hardware is nothing without software. It's a paperweight. If you have a piece of silicon that has no software, at best it's your paperweight. So you need the software to work with this. So okay, I solve half the equation, I got to do the rest. How do we solve the software problem? What's needed? Well, first, to create an ecosystem, we need a consistent compute platform. I have to build a component that you can write software on and deploy it across multiple solutions. Otherwise, you're writing software for one solution, and imagine in the case of a car manufacturer who has hundreds of models. If you have to write one software for every single model, forget it. It's not an equation you can solve for. I have to have a consistent platform so you can write software that's scalable. I have to solve the ease of use developers for the developers. There's developers in the room today, you don't care. You don't care what's underneath. You don't want to worry about that. Just make the tools and flows and make it as fast as possible and the lowest power as possible. But make the tools and flows work. So that's the other area we're solving for. And then, of course, it's got to be portable and scalable. If we can't make it scalable, we didn't solve anything. It just has to work, right? And that's what we've known for. But what we're doing is that we're extending that now. And again, let me remind you, why are we extending that? Because we know that in order for this industry to solve its problems, in order for this industry to scale, we have to solve the power problem. In order to solve the power problem, we have to do more. Because it's a system problem. Everybody knows power is a system problem. So let's talk about the consistent compute platform. Once we've solved the consistent compute platform, we can now leverage the 20 million developers that are on Arm. Arm has one of the largest developer ecosystems in the world. But now I have a consistent compute platform. So now those developers can sit on top of my platform. And great, now I solved the Android problem, iOS, Microsoft, but I also need to look at the app ecosystem. We also need to solve the problem for the app ecosystem. And so that's the other area that there's great focus. Not just the OS, but also make sure the applications can sit seamlessly on our compute platform. And let's talk about AI. I think I'm going to get a shirt that says I was AI before AI was cool, because I truly believe that we've been doing AI way, way before a lot of us even talked about it. In 2015, we released Neon. With Neon was our first AI acceleration with V8 technology. We now have our V9 technology. Imagine the progress we've made. Imagine the developers that sit on top of ARM technology because of this large progress and large history that we have in AI. And with our V9 technology, which was our latest release, we've made AI acceleration even more easy. We solved this with SVE2. SVE2 allows for imaging and video much more seamlessly on our technology. So these are accelerations. We've also added SME, which is another a way to create common instructions and better performance for AI. Between SVE2, SME, we've now exploded on the amount of AI that can sit and accelerate on top of our CPUs as well as our GPUs. So our V9 technology truly gives us a differentiated solution. The other capability that our V9 technology has is confidential compute. We can now have multiple workloads sitting next to each other confidentially. You might not need to use a hypervisor. That's going to make your product much faster. Lower latency, lower power. So V9 has truly embarked on some of the biggest transformations we've had in our architecture for AI. And then ease of use for our developers. If some of you may know, we released Kleidi.ai. It's the world-leading framework, runs best on Arm out of the box. It unlocks the performance with no additional work. As new models are released, within a day, we're able to see it working on the Arm technology. So Llama 3 was running on Kleidi within 24 hours. So Kleidi.ai is truly a leap function for us, a jump in being able to make AI models and technology sit on our IP as fast as possible with tools and flows. It goes beyond just mobile. We can do it with PyTorch, ExecuTorch. We're able to run those technologies on our Arm Kleidi.ai within 24 hours. So, portable and scalable. Proud to announce, about 4 years ago, we released Sophie. Sophie was a standardization specifically for the automotive space. And we tried to solve for 3 problems with Sophie. Software portability. That means that we now have a compute platform that is portable across all different versions of silicon in automotive. Consistent environment from cloud to edge. Software-defined vehicles in the space of automotive is survival. We have to have a way to have a consistent platform in the cloud and in the car. And Sophie creates a consistent standard in the cloud and the edge. And then lastly, you got to be able to start your software before any hardware is developed. Because the critical path now for automotive is software. So I have to start my software. And this is the 3 things that Sophie solves for. And since Sophie's release, I'm very, very proud to say we have over 140 members a part of Sophie. Sophie truly has changed this space with 140 members that are software, hardware, silicon vendors, OEMs, technology, manufacturing technology. All of those is part of this one consortium solving those 3 fundamental problems. We have 35 different workloads working on this the Sophie platform. And what's amazing is we've been able to solve problems like mixed criticality. Those of you in the automotive space know how important that is. And solving mixed criticality on top of a Sophie platform is a significant accomplishment done through our ecosystem. And we've been able to reduce the time to market or software development for up to 2 years because you can start it earlier. So it's no longer in the critical path. So what do we need to deliver to truly see this potential of AI? It's a system problem, and that's what I've been saying. Software and firmware. I've talked about that. Foundry support. I haven't talked about that yet. We got to have foundry support. Third-party IP, and expert design services. And Arm isn't really in that space. And this is why we say it takes all of us. It takes all of us. We can't solve this problem alone. Yes, we've got pieces. Yes, I told you about compute subsystems. I talked to you about an ecosystem. But we truly have to embrace the rest of the ecosystem to solve this problem. And that's why we've created Arm Total Design. Arm Total Design pulls together members across the ecosystem, foundry services, design services. Because guess what? A compute subsystem is only a piece. And if we don't have these other ecosystem members working with you, in conjunction with you, to deploy the entire solution, because no one company can do it alone, I don't give you scalability if I do it alone, then we really haven't solved the problem. And so this is where Arm Total Design comes in, to really see our dreams a reality. Yes, we can start with a system problem. Yes, we can create subsystems. Yes, we can create an ecosystem. But we truly need the rest of the ecosystem of foundry service, third-party IP, because we don't create it all, to be on this journey with us. And from this Arm Total Design, our vision is we can create a thriving chiplet ecosystem. Because we can see some of our reality of compute subsystems in silicon, and through this ecosystem of vendors that are working together on consistent architecture. And now our vision of consistent chiplets, low power, scalability, and software. That's what we can solve by creating this consistent ecosystem. So I hope I've convinced you that we're all in this together. Arm can't do it alone. OEMs can't do it alone. We're truly in this together if we're going to see the dreams of our dreams become a reality. Some of the things that I talked about, some of these use cases that are truly changing people's lives, my life included with my niece. If we're going to see this, it has to be truly all of us together. By 2025, 100 billion plus ARM devices running AI. That's the potential. That's what we can do together. And with that, we can build solutions that are significantly improving the lives of those around us. But we've got to do it with low power, because we haven't solved anything if we don't do that. We've got to think about this holistically, and we've got to think about scalability. Holistically meaning systems and scalability. We are building the future together, and I am so proud to be here with this audience. I'm so proud to have us in the same room with some of the most significant companies in the world here in Japan. So thank you very much for having me. Thank you very much. I'd like to welcome Atsushi Ogawa. Oh my God, I practiced that so many times. Atsushi Ogawa. Thank you. Did I say it right there? Of course.
That's fun. It was a great talk.
Thank you so much.
Hey.
How are you?
Good. How are you?
I am very good. Very good. Happy to be
It
here.
was a great talk.
Thank you.
Yeah, I love that
Thank
part
you.
of your
You and I
story.
talked earlier this morning, and I said, it's all the same stuff, right? That we're going to talk about AI and
Yeah.
power. And in your space specifically, at Honda, how do you see the software-defined vehicle? How do you see that's changing the way you think about creating cars?
Oh, it's everyone knows that importance of software has increased a lot and will increase more. But thing is, it's software-defined vehicle, but it's not software-dominated vehicle. So there's a room that Honda can play more, especially for IVI and autonomous driving. So especially autonomous driving, I like to start with the talk about autonomous driving of Honda. We develop our own software for not only autonomous driving but ADAS system. The reason is we have a big advantage. We know,
That's a big advantage. Very
we know,
unique.
yeah,
Very unique.
we know cars very well,
Yes.
as well as the traffic itself. So you have a long history of analyzing traffic accident for decades with many different countries. They're a fundamental knowledge for us and our advantage to develop our own software for autonomous driving. So that's our stance. So I'd like to welcome the importance of software because we have a base to cope with that.
So when you develop your own software, how do you think about, okay, so you have your software, your own software stack, then you have these hardware solutions, right? How do you think about the intersection of that software and the hardware?
Okay.
How does that work?
So like I say, it's not a software dominated vehicle. The more complex software gets, the deeper software and hardware should be correlated or collaborated or co-developed or co-designed. So it's I like your word that hardware is nothing without software.
Yeah.
But that's also true for from our side. I like to say software is nothing without hardware.
That's true too. It's just a bunch of ones and zeros. Yes.
Yeah, so software cannot be created standalone from scratch. It's fine for some modification like OTA. You know, software can be developed standalone, but if you do it from scratch, you need to know not only software but hardware. Hardware in this case means like a chips, not only like a chips or SoC, but sensors, and platform devices. Those have to be co-designed.
And that's an extremely complex problem if you think about the history of automotive, right? You have all of these, somebody makes a wheel, somebody makes a tire, somebody makes a bumper, right?
Yeah.
It's such a operational machine where everybody knows what they need to do and each of the pieces just come together. Now it's no longer so clean in your development process. Everything is mixed together. You have to have a co-design. How does that change how you think of development process? How does that change how you go to market?
So the point is, it's everybody say it's a system engineering, but not that easy. It's a systems of systems of
That's
systems.
a big word, right? But
it's so complex. But for hardware side, we have a long history of to be a orchestrator, to put the pieces together. But our challenge is that software side. I said we have an advantage, but still there are lots of room to improve. Because maybe 10 years ago, 20 years ago, we don't care much about semiconductor.
I know. I was still around. Nobody cared. You were just a semiconductor guy.
No AI, and it's more. You can develop cars more systematically.
I know.
But now it's lots of players. It's new players, which is not familiar for us, and so it's really complex.
Well, I mean, if you think about just the idea that you and I are on the stage together, right? ARM, traditionally, you think of, why is an OEM talking to ARM, right?
Right.
Semiconductors take care of that. Somebody does that, right?
Yeah.
I'll have
Tier 1,
somebody
tier 2,
just create a chip because of the importance of software and the importance of AI. So tell me, now you have all this software and all this hardware that you build yourself, and now you have this AI that you have to deal with. And you and I were talking earlier how AI is by nature not deterministic, so it throws the entire system off. How do you think about AI and how that changes how you're building?
So okay, we use AI for our OEM use AI for autonomous driving for recognition. Like CNN, we use AI, but today still most of OEM use rule-based for path planning, for example. But in next 10 years, those path planning will be replaced by machine learning deep learning,
Right.
maybe some end-to-end for
Water.
some no, stop. I'm good. For upper level, high level of scenario creation. So gradually, the AI play more, even for path planning. So that's a key. But it's not that simple because we're responsible to save people's life.
I know.
So maybe for example, the spinal reflex to the last second of collision.
Yeah.
We have to use rule base. So it's more complex. It's not just simple end to end. It's all mixed, hybrid algorithm. That's what we're good at.
And it truly is one of Honda's. When I think of a Honda car, I think of the safest vehicle. In fact, my daughter drives a Honda.
Thank you very much.
Why? Because I don't want her. I want her to be safe. I want to make sure it's reliable, and I want to make sure it's safe. And I think that's more important than almost anything else in the car, right?
Definitely.
So you have a long history of that reputation. So you talked about semiconductors and how maybe 10 years ago you wouldn't talk to me because I'm a semiconductor person. Because it is you relied on the value chain to handle those things for you. And now you work directly with semiconductors. How do you think about customization when it comes to semiconductors?
So currently we're working with players for CPU, GPU, and new player for NPU accelerator, and EDA company players. But it's
Don't talk to those other CPU people.
No.
Okay. Or GPU or ISP. Yeah, you got me.
But it's time consuming, right?
Yes. You mean I take too much time?
So I said we develop our own software, which means we have to develop or customize the hardware side to extract the performance 100%, because lots of multiply, accumulate operation go to maybe NPU, but still activation functions stay CPU, but those combination on software side are unique for us. So hardware side have to be cope with that. So that's why we have to talk with different players. It's time consuming. So your idea of consistent platform, for us, it's from edge to cloud data center. If it's consistent, we can reduce lots of lots of time for developing new things, and it's very important.
Yeah, and that's the value where Arm has data center assets. We work with Amazon, and you see a lab in Amazon that has both Arm in the cloud and Arm on the car, and that true deployment of software is seamless because it's the same parity, it's the same CPU. Both sides.
So there are lots of players, like I said, and also there are lots of OEMs. So, but someone has to lead the ecosystem to make for us to develop easier.
So that gets me to my last question here, because we're almost at the time. You have the entire Arm, well, the best of Arm's ecosystem here. You have the best of Arm's ecosystem here, and what can we do more? What can we do more to help you?
So of course, like I said, someone have to lead this ecosystem to make the world easier for us. That's not for OEM, that's for customer, for our customer, who buy our products. And but also the bottleneck is power consumption. We like to introduce level 4 autonomous driving, but it's in current situation, it's impossible. So the power consumption is a bottleneck. So that's the key. But by knowing the key issue, someone has to lead the ecosystem from bottom to top, and otherwise we just end up on the we have to stick on the issue for another decade.
Another decade. No. I'm not going to be around in this another decade. Okay. Well, thank you so much for being here with us. Thank you for being us with our audience here. I really appreciate your time.
Thank you very much.
Thank you. Thank you. Okay. So thank you for being here. What a wonderful time I've had this morning with you, and I hope that you have the most of this experience. The value of this experience is not just our presentations. We think we're pretty good, but more than that, it's you guys talking to each other. You guys talking to others is a true value. So please take this moment, spend time together, and I hope you have a wonderful Techno Symposium. Sayonara.